The essential element of a soft candy is gelatin. And we know that gelatin is made up of many different amino acids. And we know that amino acids are produced and combined into the big thick proteins that are needed to make things like gelatin inside the cell by the cellular proteins in the messenger RNA. But specifically, what amino acids go to make up the proteins in gelatin? Well, the answer is we don't know. Now, there are some that we do know for sure, but every single batch of gelatin has a complex mix of amino acids. Now, the gelatin that you buy in the store was carefully measured out by scientists in a lab or engineers in a factory to have a consistent content so that all of that gelatin is going to come out the same when you use it. That's why it's so good for Jell-O and other things. It's very consistent. However, this process of making the perfect easy-use gelatin, you have a lot more engineering than science. Now, what's the difference between engineering and science? Science is the process of figuring out how and why something works. You often take it apart and make it useless in the process. For instance, if you want to figure out how an engine in a toy works, you've got to take apart the toy and probably destroy the engine in the process. Engineering is the process of making sure something works and not really caring all that much why it works. Now, these biochemical engineers that make perfect gelatin that will always make you perfect Jell-O, and the reason that make it so that it's so easy to use gelatin to make Jell-O, they found a way to create a mix that works. But we're not entirely sure what goes into the mix, because you'd have to chemically test every single batch, and that would take too much time and too much money to do. So they make a batch that they know won't make people sick and will make things solid. Sometimes they use plant proteins, sometimes they use animal proteins. But to make gelatin, it's easiest and quickest and surest to use animal proteins because, as you saw in the cells, animals are constantly making and eating proteins. That's how your food works. Your body doesn't break the food down to the component atoms. It breaks it down to the component amino acids. So your body isn't breaking food down to random carbon and oxygen molecules and building them up again, although sometimes it does do that. But more often, your body eats the food and digests it down to amino acids, and then it transports those amino acids to the cells, and then the messenger RNA picks up the amino acid and starts building more complicated proteins with it. So animals have far more of the amino acids at a far greater concentration. So there's more amino acids per ounce of animal than there is amino acids per ounce of plants. So that is why it's so much easier to find animal-based gelatin than plant-based gelatin. So, now we have these amino acids. And again, the question is, what amino acids are in gelatin? Well, the first one, as you may have guessed from looking at the screen, the one that we know for sure that's in all gelatin is glycine. This is part of the reason gelatin starts with a GL. Glycine is an essential component, and I think you can make gelatin out of pure glycine, but getting it down to that purity is hard and not worth the expense. So, what are some of the other amino acids? Let's look at some of the other wonderful amino acids that make up gelatin. Now, every amino acid is good for you on some level. It does something for you. Here's a common one that you might have heard of, lysine, but you would have heard of it referred to as L-lysine. That is because every amino acid, all 28 of them, have two shapes, a left-handed shape and a right-handed shape. And all life on Earth is based on the left-handed shaped amino acid, to the point that you can't even digest right-handed amino acids. They're just no good to you. They just pass right through your body. So, and this becomes a problem because when you randomly chemically purify a bunch of amino acids and put them in a jar, even if you start out with all left-handed amino acids, some of them are going to immediately begin folding back into right-handed amino acids. And when you have right-handed amino acids, your body just can't do anything with them, can't digest them. The RNA molecules can't get a hold of them and use them. Fortunately for our purposes, that's not a problem in gelatin. As long as the amino acid will absorb the water, and then fold back to hold the water in place, you're going to get some good Jell-O. But where have you heard of L-lysine? It is an antiviral. L-lysine is one of the building blocks that your body uses to build its immune defense. Science isn't entirely sure why, but by taking L-lysine, it can help strengthen your body. It won't cure you once you already have a virus, but it will make your body stronger to fight off other viruses. But it costs a little more than it would have otherwise, because as soon as you put Lysine on a bottle on your shelf, some of it starts turning into R-lysine, and R-lysine just doesn't do you any good. It's not going to poison you, but your little RNA grabbers can't grab it and take it to the protein to fold it into a big molecule. So that's Lysine. Another one that is very useful and very good for your health is Argonine. Now, these are all going to sound about the same. Proline, alanine. All those names sound very similar because when we're naming chemicals, they like to be able to tell from the name what kind of chemical it is, even if you've never heard it before. Words ending in those ines are going to be amino acids. So, but it's not just amino acids that are in gelatin. There's also sugar, and the chemical shape of sugar helps bind together the amino acids. For certain types of gelatin, the one that use the plant-based proteins, which aren't as good at folding and refolding, you really, really need the sugar to help link together the gelatin. As you will see, unfortunately, one of my experiments didn't work because I used the plant-based gelatin rather than the animal-based gelatin. The plant-based gelatin is often called pectin, or other names like that, but I should have added a lot more sugar. I only used the amount of sugar that I needed for a gelatin-based recipe. You really don't need any sugar for a gelatin-based recipe, but I should have added much more sugar to the pectin if I wanted it all to fold into place. Sugar somehow, and again, scientists aren't quite sure how, helps the pectin molecules fold together and hold the water in. Now, and again, the gelatin, or the animal-based amino acids, don't really need that. That's why we still use animal-based amino acids. Now, when old people, hundreds of years ago, used to make jams and jellies, do you know which part, and I'll ask you after the end of the video, which part of the animal that was the most favored for making jellies? Alright, think about that, and we'll talk about that at the end of the video. So, there we have the chemical components of gelatin. You've got your amino acids and your sugars, such as you've got your glucose, and of course wherever you have glucose, you're bound to have sucrose. And the sucrose is made of two sugar molecules, the glucose and the fructose. There you have the chemical composition of gelatin. Alright, we'll move on from here.